All right. Last example. Let's see. We have the sum n equal to 1 to infinity of negative 1 to the n plus 1. Does it matter if now this one's n plus 1 and not n minus 1 n? No, it doesn't. Okay. N squared all over n cubed plus 1. Okay. Convergent or divergent? Okay, so the first thing that we do is we go, hey, look it, there's this negative 1 to some n power. So therefore, it's alternating. So let's try the alternating series test, right? So, is this one less than or equal to this one? Question mark. Now, instead of, you know what, when we did, let me go back to this guy really quickly. We could sit here and do this for some time, and then actually, if I think about it, if we sat there and we got a whole bunch of numbers that maybe we're not too sure with fractions, and I had to go to my calculator and put it in decimal form, and we weren't too sure if this is decreasing. But remember when we did the integral test to check to see if something was decreasing, what would we do? Yeah, we do a number line. How do we get to the number line stage first? We have to take the derivative. So why don't we, instead of sitting here and expanding, okay, let's take the derivative. Okay, so we're going to say let f of x equal to x squared divided by x cubed plus 1. I mean, I'm pretty sure this one's decreasing because that power is way bigger than that power. But let's just make sure we have another tool that we can apply. Okay, so I'm going to say f prime of x. What is this? Help me. This is 2x times x cubed plus 1 minus 3x squared, times x squared divided by x cubed plus 1. Thank you. All right, so let's see what we have. We have 2x to the 4th plus 2x minus 3x to the 4th. And this is x cubed plus 1 being squared. And so how many x to the 4th do we have? Minus x to the 4th plus 2x all over x cubed plus 1 being squared. Okay, and so let's factor this, shall we? Let's take out a negative x. And so we're going to have 2 minus, actually, I'm going to have x cubed minus 2 all over x cubed plus 1 being squared. So now, when is it going to be does not exist? It's not in this situation because this is always going to be positive because it's squared, right? When is f prime going to equal 0? When x is equal to 0 and x equal to cube root of 2. So I'll do a number line up here. We really only care when it's positive anyways because all these n's start when it's 1. Okay, so anyways, so here's when it's 0 and cube root of 2. This is when it's 0 as well. So if I put 1 in, what am I going to get? I don't know. Let me put it in here. That looks easier. It's negative 1 plus 2 divided by 2 squared. What's that? 1 over 4. That's positive. Right? Okay. And if I do cube root of 2, well, 2 is bigger than cube root of 2. Okay, so let's say 2 to the 4th is 16, so negative 16 plus 4 divided by, what's 2 cubed? 8 plus 1 is 9. 9 squared, what's 9 squared? 81, thank you. And so, help me. That is, well, who cares? That's a negative. Okay, so in this situation, it's ultimately decreasing. So, that's satisfied. Right? Now, the next part that we need to satisfy is limit as n goes to infinity of bn equaling 0, question mark. So let's check that out. So we do limit as n goes to infinity of x squared all over x cubed plus, sorry, I should do n squared. N squared all n cubed plus 1. And we know if we do L'Hopital's, we have to do it like twice. But if we divide by the highest degree, n goes to infinity, we'll have 1 over n in the numerator, and we'll have 1 plus 1 over n cubed in the denominator. And when we put in infinity, we're going to get 0 all over 1 plus 0, which is dun-dun-dun, 0. So, check mark. So therefore, this guy, n equal to 1 to infinity of negative 1 to the n plus 1, n squared over n cubed plus 1, converges by alternating series test.